first things first, a little bit of cleanup from last time. There was that one problem that took me forever. Here, let me remind you, just in case. I think I've got your papers. I need to give them back to you. Just a sec. Is that it? Here it is. Here we go. Okay, yeah. Here, I will show it to you up on the screen. Sorry. So, get the camera, boom. Okay, so it was this problem right there, the number 22. Oh, you can hardly see it. Just a minute. It's a little better. I could probably even make it better than that, but there it is, number 22. So I don't know if you remember how it took me forever. Whoa, what just happened? Okay, there. Guess I went underneath the thing here. So it took me forever to do this because I was obsessed with doing it by hand. I forgot that people use calculators these days. Anyway, so I was kind of embarrassed when I actually looked up the answer key. So here's the answer key. So I don't know if you remember well, if you don't, then you don't get to get joy in seeing what I have here. So here's the answer key. Let's see if I can find, where is this? It's over here and up one. So there it is. There it is. That's all they did. So just as a word of explanation, at first I thought, wait, how in the world did they know this? That's the thing that came to mind. I didn't even think of using a calculator. I just looked at this thinking, are you supposed to know this? And then I realized, oh, you could use a calculator, couldn't you? So if you used a calculator, you could know that the inverse sine of this is 75 degrees, and then using they didn't even use, wait a minute, they didn't even use the sum and difference formula. My goodness, not only that, yeah, that's really feeble. I'm really embarrassed for them. But, you know, they did it a lot quicker than me. Yeah, if you have a calculator, it's really kind of easy. So that was number 22. So I have all of the answers here. Yeah, so why don't I show you the answers? So we were doing number, or the, whatever page it was, the last page from this thing. Here we go. We get the answers. There's the answers. So here's the answer key. Give me a sec. Just so I know what number to start on. Okay, it starts with number 32, kind of. I know we kind of did 32 at the end of last time. So here are the, that's wrong numbers. There it is. So 32, here I'll pull this down a bit. Okay, there's 33. And notice that they not only list the answer, but they also say this is the topic, which you probably could have figured out just by, you know, you're smart enough to know this stuff. But there's 32 through 42 at least. So take a minute, take a look at those, compare with your answers, and see if you differ. And if you do, we could talk. So take a minute to look at those. I guess that's really most of just a little bit onto the back page. So was anything particularly disturbing? Or are you just rejoicing that you know how to do basic calculus and algebra? Maybe. All right. Well, you're comparing. No one's complaining. Our spokesperson? How's our spokesperson doing? Wait, you're the spokesperson for the other class. I'm sorry. Okay, Jaron? 36. 36. Let's see what 36 is. Oh, yeah, beautiful. Love it. Just a minute. Put 36 here. That way I can get a picture of it. All right. Give me a sec. Copy, delete. Okay. Let me go back here so we can do 36. Okay, so it says in the triangle below, the cosine of omega is equal to what? So what we have to remember here is this joyful formula. Oh, welcome. I thought you had decided to go down to Columbus. No, I was disappointed that, or I was excited. Now I'm disappointed. But, well, I'm glad you're here, though. I'm glad that you're not sick. That would have been the worst for sickness. Okay, so I just showed everyone the answers to all of the problems. Well, not all of them, most of them. I'll show you them in just a minute. Jaron said that He didn't get number 36 right, so let's take a look at 36. 36 is based on the law of cosines that you probably remember from pre-calculus or sometime. The law of cosine says that a squared, no, let's use c. Here it is. C squared, darn it. I've got it in my brain, I just can't write it. Let's try again. C squared is equal to a squared plus b squared. Wait, isn't that the Pythagorean theorem? Indeed it is. That's the Pythagorean theorem. The law of cosines is like the Pythagorean theorem for triangles that are not right. So these are not right triangles. So minus 2ab times the cosine of whatever angle we have here. So in terms of this problem, the angle is that angle. The way you would label this is you put C opposite the angle, and then A and B can be the other two legs. So it's kind of like a correction. This is sort of a correction factor for the fact that this isn't a right triangle, because we shouldn't discriminate against triangles just because they aren't right triangles. So anyway, now that it's probably, you could do this easily, but let's just finish it up. This will be 16 plus 49 minus 2 times 4, that's 8 times, that's going to be 56 times the cosine, if I can do my arithmetic correctly. Then a little bit of algebra, cosine of the angle. Let's just do 56 times the cosine of the angle is going to be, let's see, 16 and 49 is 5965. So that'll be -1. Oh, no, +1, because I got rid of the negative on the other side. And so, yeah, now you can see it's going to be letter A. I hope that's the right answer. What was this? Which one? 36? Yeah, it was A. Okay, very good. So, yeah, so it's these identities or rules that you may have learned at one point and that you have forgotten, but hopefully they'll come back to you. Okay, so here, I'll zoom back in, and we can see these are the answers. It was 30, whoops, sorry about that. 32 through 50 were the ones that you were doing. Okay, whatever. There's the first bunch. So any other from that first page, the first page goes up through 41. And then I'll move it, not to worry. All right, so the trigonometry, I see a theme. It seems like this was the theme from the last page as well, that the trigonometry was what killed everyone. Or not killed you, it just was hard. Yeah, so anyway, is trig, those of you who have taken the OAE, is trigonometry part of that? There's some trig. So yeah, there's not, I mean, it's not like this is all trig. You can see on the other side, where's the trigonometry? Yep, that one's trig 22. That was the one that, yeah, I showed the answer they have is way easier, the solution. And I guess you have some geometry, which might involve some trigonometry. So there's not a ton of trig on here, but there's some. I guess there's up here. There was a little bit of trig. 31 is trig. Okay, so moving on, let's take a look at the rest of these. The back page, so 42 through 50. Oh, number 49? What's 49? That's trigonometry, so I just assume that it's going to be a problem. Yes, yeah, the sum formula. Yeah, do we need to look at that one? Okay, it's amazing how, here, I'll put this up here. Let's see, where is 49? Let me just take a picture of this so I can stick it in my Notability. Let's do 49. Oh no. I didn't do that right. There we go. Let me just crop this because that's going to annoy me that it's so ugly. We don't need all that. Beautiful. Okay, that's so much better. Okay, so this is the sum formula, the one that I used on 22, but apparently I didn't need to use it on 22. You remember we had the sum formula for sine, and the sine is equal to, here I'll write it down again, the sine of x plus y is equal to the sine of x times the cosine of y plus the cosine of y, or x, sorry, cosine of x times the sine of y. So you have this sum formula. And so if you use this, this is pretty easy. You're just going to use that is x, this is y. So let's see, the sine of, this is going to be the sine of pi over 2 times the cosine of t plus the cosine of pi over 2 times the sine of t. And apparently, you can use your calculator, at least with this. Can you use your calculator on the OEE? What was the rule with that? Oh, they have like an online calculator? It doesn't graph, but it has sine, cosine. You don't think so?
No, I think so.
You think so? Okay. So it's like basic scientific calculator that they have. So yeah, so you could use sine, cosine. Yeah, so Sarah, what I was mentioning is that number 22 that took me forever last time, if you use a calculator, it's trivial. I mean, it takes like two steps. So using a calculator here, which I don't need because I know my sines and cosines, but you could use a calculator. Sine of pi over 2 is 1, and the cosine of pi over 2 is 0. So this ends up just being the cosine. And is that the answer that they gave? I sure hope so. Ah, yes, it is. Good. So letter B is the right answer. All right, let me show you those answers just one more time, just to make sure that we're all happy with this. I know I got to reposition, zoom in. Okay, there, good enough. There it is. So 41 through 50, or 42 through 50, I guess, is on that last page. All right, so it seems like it's trig, right? That's so interesting. That trigonometry is the thing that everyone's Achilles heel here, is trigonometry. So I guess that's good for me to know that in the future, maybe I need to, if I ever teach this class again, emphasize trigonometry at the front end. We certainly can. We can do them all. Oh, geometry. Yeah. Wait a minute, aren't you in geometry right now? Let's see, what is 44? Oh, there it is. Sorry, took me a minute to find it. Certain arc. Oh, yeah, because it has an angle. Good. Yeah, I'm not. Yeah, I'm not making fun of anyone. I'm trying to understand how better to do my job in the future. So don't take it as a slight if I say something that sounds somewhat negative. It's mainly that I need to learn how to do this. Maybe discuss it with Dr. Brad and Dr. Hewlett. See if we can figure out how to help you guys as best we can. So here's the certain arc circle has a measure of pi radians. Okay, so we have a circle. I guess, well, I've drawn it now. Here's my circle. The arc has a measure of the ratio between the measure of the arc and the diameter. Okay, so here's the arc. Certain arc. Wait, a certain arc. How do we know? A certain arc of a circle has a measure of pi radians. But how do we know the size of the circle? Because if you have a little tiny circle, then that arc could be huge. Okay, if I had to guess, I'm just going to guess for now, that if this was a 1 here, this is pi, then the diameter is 2, so it would be pi over 2, which is this. Is that the right answer? Yeah. That is the right answer. How do you know, though, given this, let me see what, so here is, before you came, I was showing everyone the answer that they had for 22. Let's take a look at the answer for 40. Oh, I love that. 44. Let's see, what does it say here? Okay. All right, let me see. Let's see. I guess I don't know my definitions of arc, because what they're saying there. Okay, so they're saying that the arc AB is pi times r. Call the arc AB. AB is pi times r. Wait a minute, what does this say? Pi radians? Pi radians, not pi times r. Okay, well, I think that there's a language problem here. Hopefully you won't have that on your, if you take any exam that has this. But what? Look at that. There's an error here, a typo. Yeah, there's a plus where there should be a division. That's better. Pi divided by 2. Okay, so that's what they say. I guess that I did the right thing. I just don't like their language of the arc. But there it is. All right. Was there anything else that we need? Oh, yeah, I wanted to show you. When I was looking through that, I love this. Let's zoom back out. Look at that. The answer to 48, they have it on this whole page, this tree diagram. Isn't that hilarious? I'm sure you didn't draw a tree diagram. All you did was this, probably. 3 times 5 times 6. But I just thought that was funny, that they had a tree diagram with a list of all the possible ways of going from one to the other. So a little bit unnecessary. That's kind of overkill. So, all right, anything else before we move on? Let me go back to the answers so you can see them just in case. There's the whole bunch, but there's the ones that we've done today. So we're reasonably happy, Okay, good. All right, we need to move on to, so we're happy with this stuff. Okay, so I promised you that I would give you information about the major field test. So I'm actually going to give you that information on Tuesday. So next Tuesday, I'll have the schedule up. I mean, I've got it in my brain, but I need to double check a couple of things. Got to check with the testing center as well, which I haven't done, to make sure it's okay. Basically what we're going to do is we will take a week where we don't have class on Tuesday and Thursday, and you'll do the major field test at whatever time, whatever day you want to do it. So I've got a week in mind, but I want to double check and make sure that it's okay with them. So basically, instead of coming to class for 2 hours, you'll go take a test for me for up to 2 hours. It'll be probably less than 2 hours. But yeah, I'll get that information on Tuesday, along with some other stuff about what we're going to be doing. For today, though, what we're going to be doing is we're going to be taking a look at some more elections, or not election stuff. This is apportionment stuff. So I honestly can't remember exactly what I asked you to do. And so here's what I'm hoping that we do. So we have here before us in our book, activities, I think it's, double check, let me know if I'm right about this, 9 and 10, wait, no, it's 10 and 11. 10, activity 10 is Hamilton's method, and 11 is Jefferson. Is that the same in yours? Okay, good. I was pretty sure that nothing changed. So we have those two. So what I'd like to do, I need to see if this isn't, my wife is driving up to, okay, no, it's not, we don't care. She's driving up to New York today, so I just wanted to make sure that there's not some emergency. Okay, so what I'd like to do is I'd like to take a look at, so I can't remember, like I said, I can't remember exactly when or what I asked you to do. So at some point, you're going to be doing both of these. Maybe you've already done them both. But here's what I'd like to do in here is to take a look in particular at activity 11. Here we go. And let's take a look at, it really doesn't matter which one we do, but let's take a look at the problem number 9. So this is on mine, it's on page 81. I don't know if it's the same page with you. You can check and see. I'd be curious, but here's what mine looks like. Hold on a sec. Give me a sec here. So it's this chart in particular. Okay, you can't see it. There it is. That's a little bit better. I probably could have scanned it better than that, but that's good enough. So it's this chart that I want to take a look at. And in particular, so what we'll do in terms of what is going to be due, let's see, Daniel Webster. Oh yeah, we'll start that. Okay, so like I said, I'm not sure where I am, so in terms of what I've assigned. So let's just put a pin in this and say, for sure, I will collect activities 10, 11, and 12. I'm assuming that I've told you to do 10 and 11 several times now, but on Tuesday, so here's a quick preview, Tuesday is activities 10, 11, and 12. So if you haven't done them already, please do Hamilton's method and Jefferson's method, which you probably have already done because we've talked about them several times, and then move on to Webster's method, and they talk about Adams' method as well. But let's take a look at this, and in particular, what I want to do is I want to just talk about the difference between what we did last time and what the book is telling you to do. So the way the book tells you to do it is the way that I first introduced it. This is the method some of you actually came up with. That was so brilliant, this idea of rounding everything down. When you see this INT, that's just calculator speak for round down, the integer part. So that's all they have there. So they're just saying round down these things. And they're saying you could do this by programming a calculator, which you certainly could. And in fact, somewhere I saw they had the calculator, at least in my version of the book, back at the back, they have the calculator code if you choose to type all that in. I can't imagine how tedious that would be to type all that into like a TI-83 calculator, but apparently this is the calculator code for this. You probably could adapt it for another like Java or Python or some other program. So you have Jefferson, Hamilton, Webster, all back there if you're interested. But but what they want you to do, or the way that we first approached this, is we were trying to come up with a divisor that worked for this situation. So let's go ahead and at least get started, but then we're going to use D'Hondt table for this, just to sort of actually let's go ahead and get the starting point here. So we need a total, and I don't know if the total is written here or not. So let's see. Do they have the total? It's probably in the answers. So we could go over to each sheet. Oh, they don't have the total. Huh. That's all right. So we need a total. So someone needs to do that on their calculators. And then we need to have a divisor. So they use little d for divisor. So we'll do that. And then while you're doing that, I'm going to set up my D'Hondt table. So give me a sec here. Central, east, west, wide, hill, upland, sticks, down. We'll go that far. We'll see if that's enough. Give me a sec. 1, 2, 3, 4, 5, 6. Okay. Now let me just copy the numbers. 44, 64, 37, 32, 32, 1288 and 422. Okay. All right. Did someone get the total for the entire? This is for the entire school system. 17,560. All right, 17,560. So the divisor here would be 17,560 divided by 30, whatever that ends up being. So it's a pretty big number, though. It's certainly bigger than Sticks High School. So we want to know number of representatives that we're going to get for each of these each of these um, high schools for student council or something. I think they're trying to figure out how many to have for their student council or some sort of a governing body. So one way to do it is to guess and check, but that could take forever. So like I said, I'm not sure how much of this you've done, but I wanted to get you started using the d'Hondt table because if you haven't done this, the guessing and checking can be really tedious, especially with a problem like this where there's, what is this, 7, 1, 2, 3, yes, 7 different things that we're dividing up. And so a better method is to use the d'Hondt table. So let's go ahead and get started with this. And let me remind you how you do this. And we'll divide up the labor so that this goes quickly. So we have Central High School. What I'm going to do is I'm just going to divide Central High School by 2. So this will be 2, 2, 3, 2. And then I'll divide Central High School by 3, which I can't do in my head. Although, well, I probably could, but it'll take me longer than I can do on a calculator. 1488. Divide that by 4. Divided by 4. And I get 1116. So I'm going to keep doing that. And here's what I'd like you to do is to keep doing that until you get a number that's less than Sticks High School. So I've started with Central High School. We just have to do the other high schools. Don't do Sticks because there's no sense. They're going to get 1 representative. They're not going to get 2 for sure. So, and we want 30 representatives. So go ahead and do the division and let's divide up the labor so that we don't have to all be calculating the same thing. So I will finish Central High School and then we'll have maybe these 2 here. So the gray people, Chelsea and Ralston, they could do East High School, and then Zane, Evan, maybe you could do West High School, and then Sydney and Jaron, maybe you could do, wait, what's next? Wide High School? Okay, and then we have Julia and, why can't I think? Reagan, sorry. It's Hill High School, and then I guess, Sarah, you're all alone with Outland High School. But if you need help, it's going to be the one that takes the least amount of time. So just keep going down, do the division until you get a number less than 422. And then we'll see what we do with all these numbers. Let's see. And I'll do Central. Okay. So just so you know what I did, I ended up with down here, if I divided by 11, I ended up like 405. And so that's less than this. So I was like, okay, I'm done. So it's not that we won't need that number, but we probably won't. I doubt we need that number, the 405. I guess we'll see. Maybe I should have, you know what? I'm going to write it down just in case. I just realized, yeah, we might need that number, 405. All right, so let's go over to East High School. So you two had some numbers for me. So yeah, let's just go with the integers, if that's all right. So I don't care which one of you. Do you have your list? Guess each of you. You got it? Go ahead, Rostin.
2 is 1891, then 1261, 946, 756, 630, 540, 473, and 420.
Okay, and then the 420 is the first one that's less. Very nice. Okay, so West. What about the West High School people?
2 is 1642,
Okay, so that gets below. Okay, what about the west people, or yeah, the wide people? 1,826, 619.5, 495.6, and then 430. All right, so okay, so we're almost done. So you see that they, of course, because you have smaller numbers of students, it's gonna be less uh, numbers of representatives before you end up with a small number lower than 420. Okay, Hill High School, what do you got? Okay, so then we're all done. And then Outland? 429.3. Yeah, okay, whatever. I'll just put 300. We're never going to use that number, I guarantee it. Okay, so we've got all our numbers here. And you can see this is way simpler, at least in my mind, than what Jefferson was doing in guessing, checking, going back and forth. I know this is kind of a large table here, but now what we'll just do is we'll just go through the processes to start highlighting or circling or indicating who gets representatives based on the largest average district size. That's what these represent. This is if Central High School gets one representative, they have an average district size of this much. So for sure they should get at least one because they have the largest district size. And if we only had one representative, we'd give it to Central, but we have more than one. So we start there. That's the first one, the second one, the third one, the fourth one. So we've got those taken care of. We need 30. Is that right? We're going for 30. Yes, we're going for 30. So we just keep going until we get 30. The key is to just make sure you go in order. So we're at 4, 5, 6, 7 is up there, up at Hill. And now let's see, I have to be careful. This is 8, and then 9, and then 10 is this one, and then 11. Yeah, it gets a little tricky. And then 12, and then 13. Let me get to 15 and we'll pause. That's 13. Here's 14. I think we've got all the quadruple digit numbers. Now 15, it looks like it goes to this, right? So do I have 15 so far? Yeah, I've got 15 so far. So I'm up to 15. So we can keep going, get another 15, and then we'll be all done with the apportionment. So let's see, we have 16, 17, 18, 19, 20, 21. It's getting tedious, isn't it? 22, but this is so much less tedious than doing it guess and check. Okay, so it's 22, 23, 24. I was out of order, but it doesn't matter. So we're at 24, 25, 26, 27. Of course, a computer would do this much quicker. 28 is this down here. 29 is the 547, 29, and then 30. So 30, let me just put a loop around this one because this is going to change in just a minute. There, that's number 30. So notice that the way we've done this, following the instructions, at least the instructions for Jefferson's method, Sticks High School is too small. They don't get any representatives. However, I think that there is a note in here that according to the student government bylaws, each school has to have at least one representative. I think that's what it says somewhere. But let's just assume that that's the case. Maybe I shouldn't. I don't know. Yeah, so if we were doing this just using Jefferson's method, sticks wouldn't get any representation. You get 2, 3, 4, what's this, 6, 7, and 8. That's how the representation would be. But if we were to guarantee that every school got at least one representative, then what we would do, the only difference is you would first go and highlight just the top number of all of the rows. So everyone gets one, and then you go from there the same way that we did. And so the only difference would be that would be already highlighted, and so you wouldn't get to give East High School that number there. So anyway, when you're doing these it says using Jefferson's method, I'd suggest you use, if you haven't done it already, to use either a computer, which you can easily set up Excel to do this quickly, or do it using a D'Hondt table like I just did there. Yeah, now it's bothering me. I'm pretty sure that it says that you can do this, or that they want each school to get a representative. Oh, yeah. It says here that they want each school to get at least one representative. So it says here somewhere. Um, so anyway, one other benefit of using a D'Hondt table is you'll notice that problem 10, so we just did problem 9. Problem 10 on this same page says what would happen if instead of having 30 seats, you had 32 seats. Well, we've done all the work. All you have to do with a D'Hondt table is, well, we just need 2 more representatives. So depending on how we deal with Sticks High School, either this would get highlighted, and then you'd get 2 more, and the 2 more would be, I guess, this and this, or one of those would go to Sticks High School. So I think this one, 490, that one wouldn't get. So that's a no. No, this one is yes. Yeah. So anyway, that's another benefit of doing a D'Hondt table, is that you can easily adjust the size of the number of representatives and get what you want. Okay, we still have to deal with fairness, but I guess we need to deal with the different methods first. So you're going to do those and number 12. That's Webster's method. So I need to give you a quick preview of Webster's method. So let's go back to the page that I gave you that has, let me find it. Sorry, I got to find this here somewhere. I have too many things going on here. Apportionment, there it is. So this table. So you remember this? If you don't have, I hope you still have it. We only used 2 of them. I promised you that eventually we would have, oh yeah, look down there, I said 10 and 11. Well, we'll go over it completely and deal with it on Monday, because once you have 10, 11, and 12 dealt with, we can actually have a discussion about what is fair or what's better. Is it better to use Hamilton? Is it better to use, why would someone care? Is Webster's method better? So let's talk about Webster's method really quick. We want to divide, so going back to this example, what we're going to do is we're going to divide up 18 faculty amongst those 4 departments based on number of majors. And the deal with Webster is the same idea as Jefferson. So Webster, though, he said round in the normal way, normally. I'll do this in quotes. Technically, when we say round in the normal way, that rounding is called rounding according to the arithmetic mean. Okay, so that's what normal rounding is. The only reason I'm pointing this out is because there are other ways to round, and Hill-Huntington, for example, when we get to it, uses a different way. So the arithmetic mean, what does that word mean? Well, what it means is if you're trying to round a number, for example, the number 3.71, which way does that go? Does that go up or down? It goes up. This is the normal way, the normal way. So that goes up. So this goes up to 4. If you round 3.22, you know where that goes, right? You round it down to 3. So this goes up, just a minute. Here it goes up. So this rounds up. This goes down. And what is the cutoff between 3 and 4? Like where's the cutoff between going up and down? Yeah, 3.5. I know, it's so basic. It's like, well, I learned that back in 3rd grade. You did a great job, didn't you? Anyway, the cutoff is 3.5 is the cutoff. So 3.5 is the cutoff, and 3.5 is the arithmetic mean of 3 and 4. So that's what we mean by rounding according to the arithmetic mean. When we get over here to the Hill-Huntington method, so Hill-Huntington, what we're going to do is we're going to round according to the geometric mean. And the geometric mean is different from the arithmetic mean. But let's not worry about that today. Let's just worry about this. This is easy and nice. We can do this. So Webster, you've got this. We're going to round normally. Round, that's supposed to be the word round. And so the first step is to come up with the divisor. The standard divisor is 15.278. So the divisor is 15.278. That's the standard divisor, the normal divisor. Now, because you're rounding normally, you sometimes get lucky with Webster's method. And Webster's method, so sometimes it actually works. And so the reason why, is because you sometimes round some up, some down. And so what I'm going to do is I'm just going to go up here and get the numbers from right above. So give me a sec here. Can I grab those? I bet I can. Copy. I'll paste them down here. Just a minute. I have to, there's a bunch of junk. I just have to get rid of the purple line before I put them into position. Okay. There are my numbers. Let's put them in position. So those are the numbers that I got when I used the divisor of 15.278. So if D is equal to 15.278, these are the numbers I get. When I round those numbers, I get this, 5, 8, and 1, and the total is 17, which is sad. And so you know the drill, just like with Jefferson's method, we're going to take a guess to pick another divisor, and if you have apportioned too few, you make your divisor smaller, and that will result in making these bigger. So let's see, I'm going to guess that we're probably not going to go as far as Jefferson's method. So Jefferson's method, we had to go all the way down to 13.7. So what I'd suggest we do is start with a divisor like 14, maybe 14 or 14.5. Maybe some of you could do a divisor of 14, and some of you could do a divisor of 14.5. And actually, I don't even need to write everything down because we're rounding in the normal way. So all you really need to do, 14.5, I don't need 2 columns, is on your calculator, take that divisor. I'll do 14. I mean, you could do 14 as well. I do 50 divided by 14. And on my calculator, it says 3.57, which rounds to 4. So even though it's 3.57, I don't really need to write down the 3.57. I can just write down the 4, and I'm happy. So do both of those and see if either of them works. I guess if the first one you try works, then you're all done. I can tell you right now that the 14 is not going to work. The reason I know this is because look at what I've got for the second, what is that, computer science? Yeah, so I've got 6 representatives for computer science. So I've already added 2 new representatives. I'm going to go through and finish up the D equals 14 just to show you how this looks. And so this is 9. Hey, yeah, this definitely isn't going to work. This is 20. It's down to 1. Okay. Yeah, so that's way too many. That's 20. So that doesn't work either. So we tried 15.27. It didn't work. We made the divisor too small. Didn't work. So we're looking for that Goldilocks. You know, which one's just right? So try 14.5. See if it works. You might be done with 14.5. I don't know. All right, let's see where we are. Did anyone do the 14.5? I don't know if it works or not, to be honest. It doesn't work. What numbers do you get for 14.5? You just 3. Oh, so we have one too many. So we're almost there though. So let's see. If it's too many, we make the divisor bigger. Did anyone try 14.75? It's still no good. 14.7? And did it work? Ooh, exciting. Okay, so 14.7 apparently works, and you're rounding in the normal way. And so I'm guessing that this is 3 and this is 1. Which one of those two? Is it 6 or is it 9? It's a 6 and this one's 8. All right, very nice. And that one worked, and we're happy. Now, just as with Jefferson's method, you know how there's this sort of cheater? It's not a cheater. It's a nice shortcut of, I'm looking up, I don't want to quote it without having the actual formula. It's a little bit more complicated than the D'Hondt table. And I wish I could remember the name of it. Yeah, I should have looked it up ahead of time. But there is a shortcut way of doing. Let's see if it's not right here. Oh yeah, here it is. It's called a Saint-Leger. Another French person, Saint-Leger. Leger. Here, I'll show you what it looks like. Here, I could just put it up on the screen. Here you go. Okay, so this one's a little bit more complicated. What you do is you divide by successive odd numbers, but then it works the same way. You you award the seats. So these numbers in here will no longer be the district sizes, but they'll be related to district size. And so then you award to the biggest numbers in this table. So you would have a 50, 81, 124. So we could actually try this and see if this works with this Saint-Leger. I can't. I've been trying to learn French for 3 years, ever since 4 years. I don't know any French. Anyway, let me set this up. I mean, I know more than I did 4 years ago, but I find it's difficult when you don't have anyone to speak with, except for my son-in-law speaks. So biology, just a minute. Let me copy these down, and then we'll actually do this and see how it compares. Bio, comp sci, math, and physical science. Okay. Okay, so we have the odd numbers, 3. We're doing the exact same thing. So here. So obviously the top row is going to just be those 4 numbers there, 124 and 20. So one thing that might be interesting that could push us beyond just basic arithmetic mathematics is to examine why it is that this works. So we could do that maybe next time, but I just wanted to give you another tool so that you wouldn't have to do this Webster's method using the rounding. So they talk about rounding, and they have you do this thing. There's also an exercise on Adam's method. That's listed over here. It's in section activity 12. So 10, 11, 12, we'll go over all of them on Tuesday, but for now, let's just set up this Saint Legout table. So I've got all of these, and now instead of dividing by 2, I just skip the 2. I only do the odd numbers. I just go down to 3. So for example, this, when I divide by 3, I can do that one in my head. This one I can do it, no, I can't do it in my head, can I? I can sort of do it in my head. 31.3, is it? So let me just go ahead and do it on my calculator really quick. 50 divided by 3 is 16.6. And this will be 6.6. The last one is 41. 41. It's because, yes, because I can't do math apparently. There, 41.3. Thank you. I was so excited about 12 being divisible by 3. I don't know what I was thinking. Anyway, this is easy. Divide by 5. You know how to divide things by 5. So that's going to be 16.2, is it? Divide that by 5. 24.8, is it? And this will be just 4. Dividing by 7 is kind of a pain, so I'm going to have to use, oh, that's easy. That's 7.1. But this one is not as easy. So let's do 81 divided by 7. I have 11.5. Divide that by 11. It'll be about 11. I'll do 11.1. 20 divided by 11 is 9.09. Is that right? Let me see. 20 divided by, no, what am I thinking? 2.02. I don't know what I was thinking. Oh no, it's 1.8. Guess I have to use my calculator from now on.
124 divided by 7 is 17.7.
Oh, I was dividing by 11 already for some reason. Why was I dividing by 11? Let's go down here. Let's see, it's what? 17.7. What am I doing? Yeah, that's not right either. Yeah, what is wrong with me? I should just go back to bed, apparently. Yeah, you're fine with that, right? Yeah, let me stop trying to do it in my head, and let's actually do calculator. In fact, I don't have to do very much more. Let's go ahead and start highlighting. So we're going to give seats based on the biggest numbers. So, and we're shooting for 18. We're 18 faculty, so this won't take too long. There's 1, there's 2, here's 3. Give them to the biggest numbers, 4. Here's number 5, here's number 6. So we'll only add numbers to our chart where we need them. That's up to 6 now. Now we get number 7 is this one. Number 8 is this one. Number 9 is this one. Oh, I forgot one. That one is there somewhere. I forget what number it is. But I'm okay. I'm up to 10. And I think I've got all the biggest numbers highlighted. Is that right? Oh. I don't know. Let's just push this down. Maybe I was thinking prime numbers. Where's my brain going? I need to go get a brain scan. I mean, there is that deterioration that we should all worry about. Yeah, so let's do the 9. Sorry about that. 124 divided by 9. 124 divided by 9 is 13. Okay, so let's just pause. Whew, I was trying to go fast because I see the time. Sorry. Okay, so let's just pause for a minute. So I didn't highlight in the correct order, but I have highlighted the 10 biggest numbers, have I not? All the other numbers are smaller, and I know I haven't filled these in, but they will be smaller. So from here on out, we could just fill in numbers where we need them, in the sense that the next number I highlight will be this one, and then I'll need to compare these 4 numbers, and then I'll highlight this number, and then I'll need to fill in this number will be next. So I'll just fill in the numbers that I need from here on out. So this is the next, that's number 11. This one's number 12. Now I need to know what is in the CS column in order to be able to compare it with the other columns. So I do 81 divided by 9, and I get 9. I hope I can do that one correct. So let's see, get rid of that, 9. Okay, now I'll highlight the next biggest number, I'm up to, now I've lost track, I'm up to 12. So this is number 13, 5 to go. Now I need to figure out what the next number is in the math column. So divide 124 divided by 13. 124 divided by 13. And I get 9.53. So, oops, 53. So now I'm comparing, so here's what I'm comparing. I'm comparing the 10 and this 9, this 9.53 and this 6 point. So I really didn't need to fill in all of these numbers. Those are useless. So it's just those four that I compare. The next biggest number is that 10. What is that, number 14? Let me double check. 7, 14, yeah. So I'm up to 14. Now I'm just comparing the bottom number that's not highlighted. So 9.53 is the next one. I'm really curious to see, well, it's not curious. I know it's going to work out. I'm up to 15 now. So now I need another number in the math column to compare to the others. So we'll go down to 15. So 124 divided by 15 is 8.2. So now I pick the biggest one. This is number 16, 2 to go. So now I do 81 divided by 11. I'm not going to bother with my head anymore. I'm just going to use the calculator. 7.4 I'll go with. Okay, so now the next number is this. I think I just need one more, don't I? So 124 divided by 17. So each time I'm just filling in the numbers that I need. Of course, if I had a spreadsheet, I could do this much more quickly. I think I just need one more. Is that right? 3, 7, 1, 2, 3, 4, 5, 6, 7, 8. That's 15, 16. Okay, I need two more. Can't count. Okay, so this one is next because that's the next biggest. And I'm going to guess that that 7.3 is the next one, but I better double check. 81 divided by 13 now is 6.23. Whoops. 6.23. And so sure enough, this is the next one. So what does that work out to? It works out to 3 for biology, 6 for CS, 1, 2, 3, 4, 5, 6, 7, 8, 9 for math, 1 for physical science. I have one too many? Okay, so apparently I can't count. Don't do that one. So that's 8 for math. And is that it? 3, 6, 8, and 1? Is that what we had back here? I hope so. 3, 6, 8, and 1. And it was a lot easier, at least once I got over my trying to do it in my head, than that. So your job is to do 10, 11, 12. 10, 11, 12 in the book. And then we're actually going to discuss the actual book on Tuesday. And specifically, there's some questions here about how do you think it's fair? You know these words. What do they mean? We'll figure it out. But like, what's fair? What's not? Who's going to be gypped if they get is someone going to feel like they're underrepresented? That sort of thing. So do your best with that. And we'll move on. I have homework for you from last time. So if you want to just keep that homework, I still have to give you, I'm just going to check it off. I assume everyone did it for today, this stuff. By the way, oh, sorry to interrupt. I know you want to get out of here. If you think this book would be useful to you for some reason, I know it's super old, but if you found it useful to go over this, there are 4 other practice tests back here that you can try just as a practice if you're getting ready for the OAE. This is similar material. I know it's not exactly the same, but you can certainly borrow this if you want. All right, I'm going to stop the recording if you want to come talk. Otherwise, have a great day. Stop it.